Oil spills don't happen when the sun shines. They happen 24/7. Same thing with floods, right? So using radar and then not just detecting them, but also to then quantify the extent of it. So starting to predict where the floods will go or where the oil spill will start to move to, right?
Space data can be overwhelming. Billions of data points every day. How does AI help, and what are the biggest challenges in making those insights truly reliable?
9 out of 10 times it happens with computer vision, machine learning, deep learning models we deploy. Traditionally multispectral, but now hyperspectral and some SAR as well. Decision-ready, actionable information. On our platform, it happens within 5 minutes. So every information that is extracted from your task data happens within 5 minutes. Some happens within a minute.
And with me is Shankar Sivaprakasam, entrepreneur, space tech visionary, and founder of EarthEye Space.
The access to satellites and space would have to be all the way down to the bottom of the pyramid, accessible and affordable to everybody.
EarthEye Space raised $1.5 million in pre-seed funding and has been called the Uber Eats of Earth observation. Let's unpack the tech behind this idea. From monitoring forests to predicting floods, what if satellites could help us protect our planet before disaster strikes? Today we are joined by a visionary who is exactly doing that, turning space technology into actionable intelligence for Earth. Welcome to Spacefront Conversation, and with me is Shankar Sivaprakasam, entrepreneur, space tech visionary, and founder of EarthEye Space, a platform transforming satellite data into decision-ready information for sustainability and real-world decision-making. From AI-powered insights to on-demand AI-powered information, Shankar's mission is to make space data as easy to access as ordering food, quite literally the Uber Eats of Earth observation. Welcome, Shankar.
Thank you, Divya.
Let's start at the beginning. Every great idea has an origin story. Your journey from an engineer to an entrepreneur building at the intersection of space and technology, sustainability is fascinating. Was there a defining moment that made you realize this technology could truly change how we see our planet?
It's a great question. I am not a classical space guy. I come from technology. So I worked across multiple technology companies, going back to Hewlett-Packard for a long stint, followed by OpenText and a couple of startups. So I've always thought about using technology for making things better, right, and faster and cheaper too. So when I came to work in new space with a satellite company, that was by accident. But I haven't left since then. So it's been almost 8-9 years since I've been in the new space. And what I saw in the new space, while there was this disruption of traditional space and satellites with new space, it was still very heavily concentrated on top of the pyramid. So the accessibility and affordability was defined by who had the means and the resources. So that's like having access to taxis and hired cars. So I thought about how to bring this sort of, if I can consider satellites as a way of making a world a transparent and fairer place. That would mean the access to satellites and space would have to be all the way down to the bottom of the pyramid, accessible and affordable to everybody, not just those on the top of the pyramid. Hence the birth of the Uber and Uber Eats for satellites. So it is really using the similar technologies or similar thought process and business models to how transportation has been redefined on Earth. we just brought the similar model to satellites and space.
It's amazing how personal experiences can shape such impactful missions. And what were some early challenges in developing a scalable space tech business from Australia, particularly one that works with global clients?
Right. So while we are homed in Australia, we're also homed in Singapore. So it's the structure we have is a dual headquarter model. So we are equally present in Singapore as we are in Australia, and in other countries. We are in India and Dubai and so forth. Right. So if I were to answer this on hindsight, to say if we'd only been in Australia, would there have been any different? I perhaps would think so, because being in Singapore gave access to the Asian market very quickly, and also to use Singapore as a jump off to Middle East Africa. I know there's a lot more trade now happening between Australia and Middle East Africa and increasingly Asia, but Singapore already was a natural fit. But we have early clients also from Australia, so which was good. So I think this dual locations probably helped us more than just being in Australia.
Yeah, it really shows how persistence can shape innovation. Now let's get into the nuts and bolts of EarthEye Space, the technology itself. EarthEye Space focuses on leveraging satellite data for environmental monitoring. Could you walk us through how your system actually works, from data collection to real-world insights?
It's actually quite simple. In some sense, yeah, we probably, when I say what I'm about to say, I may be almost oversimplifying, but I think therein lies the beauty of what we have achieved, right? Which is to essentially aggregate lots of satellites in every sensor modality in Earth observation, just like Uber would have, brought all the private drivers onto its platform and give you and I access to rides. We took the same approach. So we went after all the commercial operators, government operators. Very fortunate that government operators trusted us to put their dual-use satellites on our platform. And these sensor modalities, as I mentioned, varies everything from optical, multispectral, hyperspectral, SAR, thermal, RF, you name it, including greenhouse gas sensing. So to your question about climate monitoring, so essentially if somebody was interested in monitoring either the leading indicators of climate change or the laggards, they could essentially do both. So if you want to look at ongoing deforestation or some change of climate changing events, to monitor them, to be able to start predicting what that impact might be in terms of the climate, or as the climate change driven disaster itself is unfolding, such as fires and floods, to be able to very quickly monitor and mitigate, or possibly not mitigate at that point in time, but be hyper responsive or responsive very quickly to those events. So that's what the platform does. So you get on the platform, depending on your use case, whether you are interested in monitoring and prosecuting illegal fishing, or you're interested in understanding deforestation, or just methane CO2 emissions from some landfill site, you could essentially use hundreds of satellites on the platform for the use cases you are interested in.
That's interesting. So it's not just data, it's intelligence.
Correct. So we transform or translate data to what we call feeds. So it's essentially information extraction from the task data.
Let's talk about how that intelligence makes an impact. Can you give us an example of real-world use case where EarthEye Space has helped make a tangible difference, maybe in agriculture, disaster management, or climate monitoring?
Yeah. Great question. So just as I was saying, so if you take an example of flood as a disaster, not just detect floods, but also calculate the extent of the flood, right? Or oil spill. So a number of customers on our platform will monitor oil spills as they unfold, whether close to coast or in the open water. So, and detecting oil spill is already hard enough because, oil spills don't happen when the sun shines. They happen 24/7. So you need to use radar. Same thing with floods, right? When it's flooding, mostly it's cloudy. So it's rains and clouds. So using radar and then not just detecting them, but also to then quantify the extent of it. So that is very helpful for first responders, as well as also authorities and shipping lines and so forth to understand the extent of the oil spill, for example, or the extent of the flood. And as a next step, it's also the dispersion, right? So starting to predict where the floods will go or where the oil spill will start to move to, right? How the dispersion happens, taking into account of wind direction, speed, and so on and so forth. Yeah.
Incredible. Using space to make Earth safer and more sustainable. Space data can be overwhelming, billions of data points every day. How does AI help EarthEye Space turn raw data, satellite data into actionable intelligence? And what are the biggest challenges in making those insights truly reliable?
Yeah, there's multiple questions there. So as I was saying, taking the data and transforming into this feeds or information, 9 out of 10 times it happens with computer vision, machine learning, deep learning models we deploy. There are some basic indices and so forth, which a lot of people are familiar with, using traditionally multispectral, but now hyperspectral and some SAR as well. So we do deliver that, but 9 out of 10 times it's all, if I can just call that broad domains as artificial intelligence, AI. So that's what we do. So one of the things that we did from day one, not only we were solving this accessibility and affordability problem, as we were discussing earlier, but more importantly, the usability. Because if you gave a user access to hundreds of satellites, which they get, and you make it affordable, you don't need to come up with contracts worth of hundreds of thousands, millions, but, just like Uber Cash or Grab wallet for those in Asia, you deposit whatever amount and you draw down. That's still good, but you still need to have the ability to understand the data, right? Not every data is visual. Like I mentioned, there are lots of different sensor modalities, and some of those will tell you the stories that visually you can't prosecute. So deploying AI, or very specifically machine learning, deep learning models to either be extracting features or using computer vision to detect objects, so classification, segmentation problems. That's what we do in solving all the problems. In delivering that usability promise means once you get access to data, how quickly can you turn that data into information, decision-ready, actionable information? On our platform, it happens within 5 minutes. So every information that is extracted from your task data happens within 5 minutes. Some happens within a minute. So that is how we deploy this capability.
I think AI is truly a game changer, but innovation always comes with challenges. Yeah. EarthEye Space raised $1.5 million USD in pre-seed funding and has been called the Uber Eats of Earth observation. What did the milestone mean for you personally, and how did you scale the idea of on-demand satellite tasking from concept to reality?
That raise validated that. So before we did the raise, we had to demonstrate to our early investors who are angels and family offices. So it's a pre-seed round, as you said, and we had to demonstrate market traction. So we had that demonstration of that market traction with several customers who are already using from defense, government, commercial, and so that's what happened. And while it was also a validation that investors friends and families and family offices, high net worths, believed in our vision. A lot of them, some of them I may not be able to name names, but some of them are really well-known people globally, from UK, Singapore, Middle East, US, and elsewhere. So they believed in the vision and mission we were on. So some of them signed up just because they believed, and others signed up because they saw some market traction. So that's how it happened. And personally, it was good to see that I could raise. So I think that's important for every founder to realize or to believe that you could raise when the need comes. So yeah,
that's a great metaphor. It really redefines accessibility. Let's unpack the tech behind this idea. EarthEye's source fuse use workflow seems to be at the core of your platform. Could you walk us through what happens at each stage and which part of data fusion has been the toughest to get right?
The middle one. So it is. It's we made accessibility easy, which means you have the ability to source. When you want, where you want, with whatever sensor data you want. I think that's an easy part. It was difficult until we came along and solved it the way we did. So that's the sourcing part. The using part is also, if you consider you build a model and you train that model for spatial agnosticism, or predominantly that's what we do, because today you can't really get a model that is spectrally agnostic, but we have achieved models that are spatially agnostic and sensor agnostic. So it doesn't matter operator A 30 centimeter, operator B 30 centimeter, the model works equally well. It also doesn't matter operator C 50 centimeter, operator D 1 meter, the model still works well. So we've got models going that are spatially agnostic and sensor agnostic, sensor operator agnostic, but they are spectrally not. Right. So obviously, so that's the use part. So how we have built those sort of models. The fusion comes in that, how do we create spectrally agnostic models? Right. How do I take multispectral and hyperspectral data and I fuse it together? How do I take multispectral, optical, and SAR data and fuse it together? So that not just for the purpose of visually prosecuting, the models don't trip over. Right. So that is the fusion part, and that's an ongoing work. So we're doing some work. We collaborate with universities as well in that sort of deep research, because today a lot of that spectral super resolution, if I can call it, happens with deep learning models. So we are working with universities in preparing those, doing those research to essentially achieve that nirvana state of spectral uniformity. So it really doesn't matter which sensor modality, you can easily fuse them. Because in LEO, as I keep reminding people, it's not CCTV in the sky. Because not everybody, I take that back. Some people I speak to think it's a persistent monitoring, and it is not. We are not in geo, so we are not doing TV broadcasting. So which then means, how do you achieve that persistent sort of capability without having the same satellite or operator having to rely on their revisit, but by bringing the power of the scale and scope of 500 plus satellites we have on the platform? How do you bring that together as a sort of a virtual resources, like Amazon standing up AWS, and really doesn't matter whether it's a Dell server, HP server, Fujitsu server, their own homegrown server, but it's AWS cloud. So that's the fusing part, and this is an ongoing work.
Yeah, really, really fascinating. The ability to fuse data at scale really changes how industries see Earth. In 2024, EarthEye Space collaborated with Mining Pre to launch a mining space tech center of excellence. How did that partnership begin, and what lessons from mining applications can carry over to agriculture, forest, or disaster management?
All partnerships start with good intent. How well they turn up, it really depends on execution. Just like even a startup, right? You got lots of good ideas. The startups that succeed are the ones that are able to execute. So with Mining 3, we had meeting of the minds, right? In terms of mining, where Mining 3 was focused on mining tech, and we were focused on space tech, so Mining Space Tech Center of Excellence. So great intent. How well have we executed on that? I would say below average. And it's because of a number of reasons, right? So obviously, when you're solving some wicked problems, you want to get into these partnerships to solve wicked problems, not easy ones. The question is, then do you have buyers? And what are buyers' alternatives to the one you want to solve from space? So we kind of can get lost in that. So I think that was one of our lessons, is that unless you have an anchor customer who has a problem statement that 1 + 1 is equal to 3 or maybe 5, we thought it would be, can solve it, then, these partnerships are just that, they probably just stay as MOUs. So that's been the lesson. But the conversations and the thought process and some of the applications we discussed, they have applicability in other industries. So for example, if you're looking at subsidence, mine subsidence, and you have the same issues in plantations, soil subsidence, right? So you bring the similar approach to how you're looking at mine subsidence and in soil subsidence, and if you're looking for some of the one of the other issues is greenhouse gas, right? So emission of certain toxicities or chemicals and greenhouse gas from either tailing dams or elsewhere in the mine area. Mine shafts, they cause a problem, but the similar approach to sort of detecting and monitoring in whether it's plantations or in agricultural land would be quite similar.
Interesting. Let's talk about that in more depth. EarthEye uses AI for anomaly detection and sensor fusion. Could you walk us through the type of models or architectures you use, and how you see AI evolving to transform Earth observation over the next decade?
Okay, so if you're referring to model anomaly, okay. So for example, we could end up in a model drift, right? So potentially we could end up in a model drift, and that could start to create some incorrect inferences. That would be an anomaly. So we have to put those MLOps processes in place to continuously monitor the models to make sure they're not drifting and you're starting to degrade your F1 score and so forth. So that would be one way to manage. That's what we do. We continuously train, but recently also we found that some of our detection models, which were developed a year and a half ago, they were tripping over when the environment where the new detections inferencing were to happen had looked completely differently than how it was trained. So it was having some false positives. So we had to retrain the model very quickly. So those are the things we do. Yeah.
I understand that, behind all of this intelligence lies a massive data engine. Yeah, I would love to peek under the hood a little. As EarthEye scales globally, how are you managing the computational demands, and what's been the most technical challenging bottleneck so far, whether in model accuracy, latency, or scaling user access?
So when you work in machine learning, deep learning, they're already data heavy. And to top it, we work in images, right? We work with imagery, and some of the imagery can run into gigabytes, hundreds of gigabytes, especially when you are dealing with hyperspectral data across hundreds of bands, or SAR, very high resolution SAR. So to use lots of different types of data for training purposes, you have a storage issue, you have a computational storing, computational issue in terms of training your models, and then we use a combination of CPUs and GPUs, but we use cloud. We don't. We are asset light, right? So if you are going to be like Uber for satellites, you might as well stay true to that model that you don't own any capex. So we run everything on the cloud, and that's how we managed that on off peak demands. We don't have a latency problem. I mean, as far as if you're referring to inferencing, we don't have a latency issue there. Model accuracy is always an issue. So we could be running certain models at a very high F1 score of 99.99, or it could be running at something as low as 0.8, 0.85 in that region. We don't deploy any model less than 0.8 or 80%. It starts to be problematic for our users. So you can't get 2 in 10 wrong. So that's a data-driven challenge. The type of data, not necessarily the quantum of data. So it's sometimes also quality of data that we have to deal with. So those are some of the challenges we face.
So how do you ensure interoperability between different satellite constellations, given that every provider has unique data formats and spectral characteristics?
That's a great question. So it goes back to that the kind of spectral standardization we talked about a while before. But when we are enabling multi-sensor tasking, right? So we're arguably the first platform that enabled multi-sensor tasking. So what that means is you could combine any sensor modality from any operator, regardless if it's commercial or government, in a single workflow, in your area of interest and time of interest. And that's how we became known as Uber Eats, right? Because of that capability. So from Uber to Uber Eats. So in terms of, just to keep it simple, we make sure the data that is delivered is what the user wants. Number one, if the user is after the feeds, then we know the data that we need to pick up and transform to run the models on. All that happens on the platform. But if the user says, I want, raw data, near raw data, so they might say, I want an L1A or L1B, or somebody might say, I want, L2A or L3. So these are all different levels of data, everything from, radiometrically, atmospherically corrected to auto-rectified and highly georeferenced with your local GCP. So all the different sort of levels of data that the user wants is delivered on the platform. But end of the day, all data is delivered as GeoTIFFs, and they are essentially GIS-ready data as well. So you get the GeoTIFF data, you get the metadata that goes with it, which are GIS-ready. So that's how we make sure, regardless of what sensor modality, the data delivered is exactly of the same format over the area of interest and the time of interest it was collected. One of the things we do, which is a harder problem I think we solved, this goes back to multi-sensor again. We don't have a satellite today that can carry multi or dual or more payloads to collect different types of imaging. Some operators have attempted to collect multispectral and hyperspectral. Hasn't really worked out because you end up doing either or, right? So you don't do simultaneous collection. There are companies that are talking about collecting optical or multispectral and SAR together. We have not seen that yet from space, but those missions, work in progress. Of course, combining image data with non-image such as RF, that's been done, and that has some interesting use cases. So how do you then get customers to collect, or if you have a use case or need that requires a multispectral or optical in the visible range data together with SAR. Let's just assume for a moment that you need those two simultaneous collections. It's not possible today because there is not a single bird that carries those two payloads, because architectures of SAR satellites are different from optical. But what we do through our multi-sensor workflows, we get the satellite passes of all these different satellites, operators, constellations on our platform, and we bring them to close together. So the customer couldn't care how that happens. They just want two data sets to be collected around in the same area around the same time. So we get those satellites to come as close to each other as possible. When I say get them to come, from the time of their passes over, we select those and we task them together. So we have seen that kind of tasking can happen anything from 15 to 30 minutes difference. So imagine you have an optical going over and collecting 50 at this moment, and another 15 minutes later, a SAR goes and collects. That's the closest you're going to get in terms of that as an alternative to having optical and SAR on the same bird collecting simultaneously, which has never happened before.
No, I can really connect to what you're explaining as an aerospace engineer.
Right.
So it's also interesting how these challenges multiply.
Right.
When you are pulling imagery from dozens of constellations. So does EarthEye use any cloud-native geospatial processing frameworks like AWS ground stations or Google Earth Engine, or is it built entirely in-house?
No. So as I mentioned earlier, we use public cloud. So we use one of those hyperscalers you mentioned. So everything we do in terms of the platform itself is hosted on the public cloud. The data is processed on that same public cloud, and that source fuse use workflow happens on that public cloud. And we also deliver the data to customers' target delivery. So it is not the data, the satellites are tasked, data is delivered on the platform and the models run to extract the information.
Yeah.
But we also have customers who want the data to go directly to their target location. So on the platform, they could say, I want this particular task data for whatever reason, go directly to my target location. That could be in itself a public cloud. It could be a secure FTP environment. It could be their GIS infrastructure. Yeah, so that integration exists.
Of course, I think the data is as powerful as the models interpreting it. So let's dive into the AI side of things. Training AI on Earth imagery is not small feat. The planet is always changing. How do you train AI models to deal with dynamic real-world variables like seasonal vegetation changes or varying illumination conditions in imagery?
That's a difficult problem, and you eat an elephant bite at a time. so we've kind of taken the same approach. So we understand the variabilities that affects the information that we are looking to extract, which then means, it's garbage in, garbage out, right? So if you're relying on a highly homogeneous data that you've used to train, you're going to get the same answer or wrong answer, right, depending on the context. So we have to vary those environmental factors in terms of, I remember when we did a SAR-based model training, we had to, while you talk about SAR being 24/7 weather agnostic, which is all true, but we found there was nuances of the data that was collected with SAR in certain times and environmental conditions, right? So the backscatter values and so forth. So So we try to work through the variability as much as possible and provide that contextual training. So when that situation is presented in the future, when the model needs to infer or extract that information, that context is embedded. So that's the hard work, harder than just training the model to be agnostic. To be aware of those variabilities.
So in Earth observation, AI often struggles with ground truth validation. Yeah. How do you verify model accuracy without consistent labeled data?
Ground truthing is important, but we also don't rely on ground truthing. So it's a double-edged sword, because we are relying heavily on data to provide the ground truth. So if you're training a model, we will look at some alternate source of data that could be satellite data themselves, but perhaps very high resolution, which in itself is not used for our model training, but it's used more for ground truthing. So, instead of somebody actually visiting the site and verifying, we use very high resolution data. Or it could be also other domain data, such as aerial and drone. So this is one way to overcome, human-driven ground truthing. So that if you form that as a baseline, then obviously every training starts with labeling. So we do in-house labeling of our training data set. We have a validation set. So usual, we have this 70-30 split of every model we train. We have 70% of the data going into training and 30% for validation. And then we use further this very high resolution as a ground truthing, and that could come from various sources.
So how do you handle model drift over time as sensor resolutions improve or atmospheric conditions change?
So we have to, if you don't keep continuously training the model, you will invariably have this drift issue. I think that's one of the main things we do. And when we get a new source of data that the model has never seen before, we test it first and see how the model performs. Could be 50, 60, 70% accuracy, and then that gives us a understanding of the delta. So we would then do the necessary training quickly to make that agnostic models that we develop.
Yeah, that's such a key point. And I have noticed that as new sensors or resolutions come online, model drift becomes inevitable. It's fascinating how platforms like EarthEye Space are building resilience into that feedback loop. Let's see into your sensor fusion and data pipeline now. So the source fuse use model is quite intriguing. Could you explain what happens at each layer technically? For example, what type of satellite data sources are fused, and how do you maintain spatial temporal consistency?
You have a situation where you need to persistently collect. And then again, you can have two scenarios there. You need to persistently collect. That means you're doing morning collection. You're doing some collection throughout the day, and then as the sun sets, you automatically need to switch to SAR. So that sourcing of persistent collections across multiple sensor modalities, depending on the weather, such as cloud cover, or the time of the day or night, in which case also different sensor modalities such as SAR would take over from optical. Those workflows are already in place on our platform. The user doesn't have to say, because the sun is shining and at this certain, the cloud cover is certain percentage or whatever, I'm tasking some of the optical sensors, and then in the night I need to go and task SAR sensors. No, I define my context, which is the area of interest for whatever reason. Could be a national security issue or could be a disaster issue or something else, and I want persistent collection. The platform will do the persistent collections by deploying the appropriate sensors, right? So that's the sourcing part solved, right? Made it frictionless, right? So traditionally they would have had lots of different frictions around it. That is now become frictionless. So now you get all this data, right? So you are after certain use case, which meant you need to, if let's assume you need to run a model on one extreme and the other extreme, you just want to see some change detection, some comparison, right? So you could look at these different images comparatively through naked eye. So you also need that visualization capability. So these are the two extremes, which means there is the middle part of the fusion. The fusion at a very basic level is I just bring the data sets that is collected onto a single view, and then you are able to make sense out of the differences, if that's what you're after, across different data sets, and in your context of area and time that those data have been collected. To the other extreme of the data needing to be fused. So when the model runs, you can still run. There's a step before we do. We run the model on, let's say, optical, and then as the SAR or thermal or whatever gets delivered, you run the models independently, right? And you make those inference and that information available respective to the data, again, to be visually prosecuted, as an example. So those are the easy parts. The difficult part is when you need to have the model run on a seamless mosaic of the data that is coming from different sensors. So then the level of difficulty varies. If I'm just looking to fuse different multispectral data of different resolutions, no problem. So that is the spatial resolution fusion that we are working on. So it doesn't matter within the multispectral 4, 5, 6 bands if you are bringing two sets of data, or spectral super resolution or normalizations where I get multispectral and, as I mentioned earlier, hyperspectral. I might collect at different times, but when I fuse it together, I can create a seamless mosaic. Or better still, I simulate my hyperspectral from my multispectra.
Okay.
Right. So because you get limited hyperspectral, you get a lot more multispectral.
Yeah.
Right. So how do you then start to simulate that by having a reference bands or hyperspectral bands to your multispectral, if the use case requires as such, right? So it all, end of the day, they are all use case driven. Same as bringing optical and SAR, whether it is for very basic thing as gap filling, and the gaps could be because of cloud on when you do an optical, or it could be just the fact that you needed an area to be covered. It covered 3/4 of it because of the direction of the path of the satellite. It covered 3/4 of your area of interest, and the next satellite, and that may not be the same type. It could be a different sensor modality, came along and covered the other quarter, right? Or the 1/3. And then you need to seamlessly mosaic them so that when you run the model, it looks at that entire scene, which has been put together with two different sensor data. So those are all the fusion challenges that we work with.
The fusion part really sounds powerful.
It is, because it removes the need to depend on a single operator.
Yeah.
Which is what happens today, right? So it's like depending on a taxi company to go from A to B or B to C every day. But when you have Uber, you can go A to B with one Uber and B to C with another driver, and not the same taxi company. Because when you rely on one operator, you're constrained by the number of satellites they got. So if you take the largest satellite operator outside of China, it's got about 17, 18 satellites. We have over 500 satellites on our platform. So the scale and scope is different, and we operate across all the different orbits. Every Earth observation orbits on our platform has satellites, both optical and SAR.
I feel like I'm sitting in the lecture today, like a lot of concepts is becoming very clear for me. I think I'm learning a lot from your explanation.
I'm glad it's made a difference. Thank you.
So is your fusion process fully automated, or is there a human in the loop mechanism for quality control?
For sure. Yes. So you can't automate away everything. So we do automate away everything as far as the customer is concerned. So there is nothing that customer or the user on our platform has to do. They never ever have to, unless they want to, write an email, pick up the phone and call us. Don't have to. Everything is on the platform. Even generating a quotation is on the platform. Invoicing is on the platform. Budgeting is on the platform. Receipts on the platform. Credit notes, credit memos, everything that you need to deal with as an enterprise or as a small business, we made sure everything is self-service, everything is on the platform. You don't ever have to contact us. Yet you can contact us. So there is on the platform, you can contact us, and there is this CSM support, customer success manager support, and all that good stuff. So that's the automation part as far as the customer is concerned. Now, to give that level of convenience and that frictionless experience for the customer means that we do the hard yard behind the scene. Like you said, you want to lift the hood and see what's underneath. So we do a lot of automation in-house ourselves. We're a very small team. People are surprised.
I'm really surprised the way you're explaining. I just want to come and join your company.
Oh, you're welcome. You said you're an aeronautical engineer. Yeah, I'm sure you appreciate this. So we are a very small team, and that means we rely heavily on automation in-house too. Having said that, we can't completely rely on automation, and so we do have human in the loop as far as quality assurance is concerned, right? Whether that is on the platform feature functions we release or in the models that we deploy for feed generation.
So once you have processed and fused all of this information, how do users actually engage with it? Or let's talk about the platform itself.
Yeah, good question. Yeah. You get on the platform, you task satellites. Some people are on the platform just to source the data. And that's all they want. Either single source, multi-source, that's all they want. There are others who want the data, but also wants the information automatically extracted because they don't have a big, let's say, analysis or GIS teams. Then there is a third category who couldn't care about the data. They just want that information, right? They just want to know how many trees are in their plantation, as an example. That's it. They don't care how it was done, so long as it's an accurate count of the trees in the plantation. So we have these different personas, right? Customer personas. So we cater to all of these. But the platform then works based on the customer intent. You could ask for feed, or you could ask for data, or you could ask for data in the feed. So once that intent is understood and the customer engages the platform, if you only want the data with a single sensor or multi-sensor, as the data arrives, you get notified, you log on, you see the data, you visualize, you can download it, you can leave it there. Or you have, as I mentioned, your option as when you're tasking to say, ask the data to be sent to, ask the platform to send the data to your target location. And you can do that case by case. So instead of you downloading and taking it away somewhere, the data will go straight to your target location. When you want information to be shown or extract the information on the data shown together with the data, we have this visualization capability on our platform. It's called collection screen. So on the collection screen, you see not just the data, but the information that was extracted from the data. So you can see the oil spill, but if you find it difficult to make out oil spill from the SAR data, you overlay the extracted information, which is GeoJSON. It'll show you exactly where the oil spill in that SAR data is. And we also do one thing. So some difficult ones, if you are not very sure, and there's a threshold to say what we are not very sure about, we say possible. So this is definitely oil spill. This is possible oil spills. So it's different from false positives. It is a bit on the gray side. So that is to make sure that customers understand that further process validation is maybe required when there is possible scenarios. So we deliver that. So as I was saying to somebody the other day, you can wait 2 weeks, 1 to 2 weeks, to get a oil spill report from certain satellite operators or some analysts or some intermediaries, or even few days. Forget even 1 to 2 weeks. Right? Some takes 1 to 2 weeks to really make very good report about the oil spill. Some may take days, with 95, 97% accuracy. Or you can get 85 to 90% accuracy, anything upwards of 80, within 5 minutes of the data delivered.
It's amazing.
That makes a big difference in terms of the decisions you need to take with 80 to 85% level accuracy today, now, as a situation is unfolding. Could be any situation. That's why we became known as a situational awareness platform. Right? We are a situational awareness company offering a situational awareness platform because data to information is always under 5 minutes. So long as it's about 80% accuracy. It's not going to be 99. It's some scenarios we run models that are as high as that. But most of the time, it's about that low latency information delivery for you to take an action now rather than waiting for hours and days.
So if we can talk on, like, as you explained, I remember a situation. If you remember, this guy called Hamish Harding. Mm-hmm. Hamish Harding, they wanted to visit Titanic.
Oh, right.
And it imploded. So these companies took, I think, quite some time to actually realize what happened. So,
you're referring to the underwater
Ocean Gate.
Yes. That happened a couple of years ago.
Yeah, I think in 2020.
2020 during COVID. Just after COVID. Yeah. Yes. I do remember seeing that. Yeah. There was a movie made out of that unfortunate incident. Yes.
Yeah. So, is there a way that EarthEye Space can detect such disasters as well? Like, because Ocean Gate and some other companies, they took quite some time to exactly know what happened, whether it imploded, exploded, or
I often get asked if you were around when MH370 happened, would we have seen some evidence of some wreckage and so forth? My answer is possibly, right? Because when you have so many satellites with very quick coverage around the world, anywhere, anytime, it is possible, unless it's going to go down very quickly, sink very quickly. If you had few hours, right, anything from 2, 3 to 6 hours time window, it is possible if you knew the kind of roughly the area, because some of the sensors we host on our platform have a very, very large swath. So there is one particular sensor, single sweep, single pass, you can collect 6,000 plus square kilometer. Just one seed.
So doing this, you are explaining something as Savoir software. With Savoir, there is a software called Savoir, SAVOIR, I guess. I remember.
Savoir, okay.
Yeah. So in my master's, I have done this SWOT analysis.
Yes.
So
okay. Right.
I'm just trying to.
Oh, I see. So the concept of SWOT is like when a satellite takes a image, there's a SWOT is fixed.
Yeah.
You can vary the length, but SWOT is fixed based on your camera and your telescope, right? As to the field of view, how much it can see. So we have sensors, as I was saying. The swath is so large, and the length also determined by how much power you have and other factors, right, including storage, how much you can collect in a single shot, right? How long you can keep the aperture open. So we have one particular sensor which is particularly interesting that can take, the point I'm making it because when you're collecting something like 6,000, 7,000 square kilometer in a single capture, and if you did it a few times, your ability to see needle in a haystack become a lot more easier. It's not going to be, I don't want to make it sound like it's possibility. It becomes a lot more easier.
Yeah. So you describe EarthEye's service as tasking as a service.
Yeah.
Could you elaborate on how users actually interact with the platform? Is there a REST API or a visual dashboard for satellite tracking?
Right now, it's all visual. It's a UI, web UI. It's a secure platform. It's two-factor authenticated, encrypted, and all of the good stuff to keep it safe. We get a lot of attacks, as you should expect, because once you break into a platform, means you have access to hundreds of satellites that you can task, which would be a disaster. So we try to keep it safe. Now, so being on a hyperscaler also helps that intent, that requirement. We're also going for SOC 2 from a security standpoint. So confidentiality, privacy, security. So those are important for our customers. Given 50% of our customers are defense, government, and so forth. So use that web interface today securely to task and collect data and information. We have intention to turn the platform into open APIs so that other platforms can integrate to it. That's probably 2026. That will unlock a different kind of go-to-market for us in terms of potentially some new partnerships. It's a platform to platform, right? Like machine to machine. Having said that, today we enable embedding. So that's the thing we do is we embed our platform as a white label capability in third-party applications and platforms. Right now, it is with our customers. So we'll have defense customers who have their C2, command and control systems. We sit inside their C2s as a real-time tasking and near real-time information platform inside their C2. So it's embedded. We control that embedding. So anybody can't embed us into their third parties and into their applications. So that's how we do this integration today.
With data across comes responsibility.